Welcome to my session. Welcome everybody from being here. This is a strange session because I really have this mania of automating stuff. And I had this strange idea to automate the diagnostic of a production application. This is the main thing. I am Raffaele Rialdi, and I am quite a usual speaker in CodeCamp and in other events around the world. I'm a proud member of the big family of the MVPs. There is also the icon of my book here that me and other two authors wrote a while ago. And I hope to see you very, very soon in person at the next event. And if you have questions about all this stuff, please feel free to ask. Our goal for today is to automate the diagnostic process, but in production. We know that, I mean, as soon as you are in your development environment, you already know all the tools, of course. But of course, it's very different when you have problems in production and you want to grab information. So basically, there are two steps to achieve this goal. That the first one is triggering a diagnostic and to understand when is the right moment to trigger a diagnostic and to capture the required data to understand what's going to happen. And this will be made thanks to a pretty new, I mean, a few, maybe 1 year or two that is out there, the Diagnostic Client Library from Microsoft. And the second step is that once you know that it's the moment, it's the right moment to capture some data, you can programmatically analyze the process that is your application that is giving some trouble. And so I don't want to instrument my production application with the diagnostic. That's bad. I mean, because I don't want to fill a lot of tooling, strange libraries, or weird code, diagnostic code inside the production application. I want to keep that clean and instead use an external tool in order to grab the information and to investigate that. So we will see we have two different applications. The production application, whatever it is, and the diagnostic application. And of course, we need some library to investigate another process. And we will use CLRMD, which is pretty well known, but starting from the 2.0, it has very exciting features, and we will see in a moment. So you normally, at the development time, use Visual Studio, Visual Studio Code, WinDBG if you are on Windows, of course, or LLDB on Linux, and the SOS. The SOS is a plugin, maybe you don't know it. It's a son of Strike. It's a very, very old plugin that was born together with the very first version of .NET framework. And it's a kind of helper, let's say, that lets you understand the specific structures of the objects of the CLR in a native way. So you have a very deep understanding of the objects, of the memories, of the threads, and so on, of all the structures in .NET, but from a very low level perspective. And unless you are analyzing a dump, you usually don't want to use them in production. I mean, those are tools that I have seen WinDBG installed in production, but please don't do it. I mean, it's not a good thing. I generally prefer to grab some data and then go home and say, okay, let's see what happens. I don't want to investigate something live with the customer that's putting my eyes on the keyboard and so on. That's too bad. And of course, you also have the profilers. You can monitor an application. And this is very important because you can see how does it perform, how it's going. You can read some data that can give you exactly the performance counters, let's say, that can give you exactly the status, the of the application, and we will use it, but in a different way of what you normally do with profilers. And preemptive profiling is a different thing. Preempting profiling is something that you can do on your development machine when you want to understand exactly if there is something very, very small, like really few lines of code, even 2 or 3 lines of code that are not performing good. I mean, it's something that you don't know exactly what is happening there. If you maybe made some mistake in putting together a number of lines of code, and you want to make a micro benchmark. And micro benchmark is important to give you numbers. And from these numbers, you discover if those libraries can be used together in a good way, if there is something bad, and so on. And is another way to do preemptive profiling. Of course, there are the debugger. The debugger is a very large topic, and I had the occasion to write an actual debugger for .NET, and it's very difficult. It's a completely separate debugger from Visual Studio or Visual Studio Code. You know that OmniSharp has something similar, but you cannot use that separately from Visual Studio Code because the license does not allow it. And so I had to write it for a customer, and it was an exciting adventure. And if you're interested in such topic, please let me know. I can arrange a session on that. But I guess that there will be not so many people interested. What about troubleshooting in production instead? So when you are in production, of course, the primary source of your help is the log. And logs are good. I mean, you can understand a lot of things, especially if you have exceptions or things like that. But I mean, most of the time you don't have enough information, and so you don't even want to put too many things inside the logs, because otherwise it becomes impossible to read it. And so this is a good start, but not necessarily the ones that can solve the issue. Creating a dump, and for example, you run the application in production, you see that it's slowing down and say, oh, how crappy is the application? I cannot run it in any way. It's something is going very bad. And you at that moment take a dump. Why not? It can be a solution, but frankly, it's not always a good solution, because at the moment that you capture the process, maybe the problem is already gone away. So you spend a lot of time in investigating in the dump. You don't know exactly what happened. And I mean, you cannot really have a cause-effect relationship. And so it's quite bad. Anyway, certain time you're lucky, especially if you have memory problems, and you can make a .NET dump, a process explorer, task manager, of course, and also giving the application the ability to self-dump. Why not? Because it's definitely possible. But catching the perfect moment, it's hard. And then you can also monitor performance counters in production. Of course, you have very interesting tools like .NET Trace, .NET Counters, and .NET GC Dumper is relatively new. And of course, you capture some file that you then analyze with Performance View, which is a great tool that I strongly suggest to use always to understand what is happening there. And by the way, in .NET 5, there is also this .NET Monitor, which is a web application, a very small web application that is able to connect to your production environment, and you remotely from your browser can investigate and read the counters. So this is a very good tool that you may use sometime. But once you discover that you maybe are filling the memory and you are using a really huge amount of memory, and then what? So it's just a piece of the puzzle, it's nothing more. So there are challenges in analysis and dump analysis, because picking the right moment is difficult. We already said that. And also, if you then analyze manually the dump, you have to type a lot of command, because the SOS commands is like very similar to the normal WinDBG commands or the LLDB commands. They are boring. They are hard to remember. You can type for, infinite times, because if you discover that you have 1,000 allocations and there is only the 10% that are bad, you have to repeat the command infinite times. It's extremely boring and expensive, of course. And also there is another problem, that when you take the dump and give you someone to investigate on the problem, you have problem with the sensitive data. Maybe the application is installed in a hospital, and you have a hard time in getting the required permission to investigate a dump, because there are privacy constraints. The GDPR EU regulation is very explicit for that. And also, if you are in the financial environment, it's a kind of nightmare. So that's so bad. That's where the automation can make a huge difference. So what is today's scenario? I want to demo a little bit, and then I will show you the code, of course. We have this application. The application on the right is our web application that is running something that is going not so well in production. And it is, of course, an ASP.NET Core application with controllers, with some services, whatever else you can think. There is nothing inside this process that contains debugger-specific stuff. And this is important, because I don't want to put too many weird stuff and weird code inside my application. On the other side, you, of course, have many clients. And since we are in a demo, I replaced the many clients with a stress application. And this stress application is a simple console application, making a concurrent number of requests when they are needed. And you can make gets, you can make a lot of posts with the web APIs, simple post, you can cause some exception, you can getting the request going slow with the thread sleep, by the way. And you can leak some memory structure, you can leak an entire graph of objects, you can free them if you want, and you can also play with GC collect if you want to see what happens when you free the memory, and also stressing some memory. We will not use all of them in the demo. I will show just a few of them, but if you want experimenting, of course, I will give you the repository on GitHub so that you can experiment and try by yourself and see how it happens and so on. You can play with it. And there is also the possibility to add a custom header inside those requests so that I can, let's say, use it for manually triggering a diagnostic. We will see in a bit. On the other side, side by side, there is another process on the same machine running with on localhost, of course. So this cannot happen on two different machines for security reasons, of course. We have the diagnostic application, which is the core piece of our application. And of course, when you go in production, you don't want to use this use a UI for this application. You want simply a headless application that is able to connect to our process and to, let's say, make some handshake to understand how can I monitor the application and how can I grab the required information. We will see in a moment. This application has two libraries, basically. The diagnostic client, which is the one needed, to acquire the required, let's say, triggers. So what are the causes of suggesting that there is something wrong. And also CLRMD, which is the investigating library. So the one that can grab the data and bring the memory process to your side. So you basically have two steps. The first is subscribe trace events. Oops. And the second one, use them as triggers. And as soon as I see for the counters, the trace counters, that I have something going weird. For example, the memory is growing up and the CPU is spending a lot of time somewhere and so on. You want to subscribe these events and make a snapshot of your application. What is a snapshot? Well, snapshot is very similar to a dump, but instead of a dump, this is much faster. So it's a kind of strategy to capture the essential part of the memory so that you can make really a photo of your other process and acquire the situation as it is in that exact moment. And this gives you an important advantage because as soon as you see the trigger going crazy in some way, in that exact moment, you trigger the snapshot. So you are pretty sure, I mean, the interval is very small, in which when you can exactly capture the memory process in that moment. And once you get the snapshot, you acquire all the stuff, and finally you can start investigating. And so once you have made this step, you can really forget about your application that we will continue to run. So you don't have to, I mean, you don't give any interruption to the customers that are there. They will be freezed for, let's say, 100 milliseconds, maybe 200 milliseconds, but nothing more. And yes, this is, I mean, disruptive in certain cases because 200 milliseconds is a large amount of time from a certain perspective, but it's the minimal amount of time that you will see a kind of small stop, and you gain the advantage to understanding what's going wrong. And once you have done that, you can continue to monitor your application if you want, which is running, is well going, and so on. And you start investigating your snapshot. By the way, this communication that you see with the blue arrow is something that lies inside the CLR of every .NET Core application, starting from 3.0, if I don't remember, if I remember well. And these other red is something that is always available. So it's also available in .NET Framework application. But this communication between the CLR of your application production environment and the diagnostic client is something specific to .NET Core. And it's something that works only on localhost, of course, because of the security constraints that are there. And it is, this means that you don't have to add any code here, but you can monitor any application that you have the permission to. I mean, every process runs with a token, and so you have the permission to access that. And you don't need admin permission, of course, because if you run with the same credentials, they have the permission. And here we are. I mean, once you have this, you can start investigating. And since we are in a demo and we want to show something, instead of a headless application, I created a WPF application, a kind of full application, UI application, that is able to show you what are the possibilities that you have there. Of course, my idea is not the one to investigate with a human being in front of the screen. The idea is that you can understand automatically from those queries that we will see, how can you understand that there is something wrong? And you have all the time to do it because you are not talking with the running application. You can really take this snapshot and start analysis that can even run for hours if you want. I mean, it's up to you. And once you obtain the information you need, and you discover that certain objects should not be there, even if there are only 2 customers connected, and what about 10,000 of these objects when there are only 2 customers? There is a leak. There is something that is wrong. I mean, this is the point. You know your application, and so the queries can be made specific to your use case. You can customize the tool so that you can make the research of the problem much specific, and so you will find what exactly you want. And so instead of typing SOS commands that you can see here, I gave this slide a long time ago in one of my sessions, I want you to show what inside these repository, and let's go straight to the code. So this is the solution, and we have the test web application. And this is the website that the production website. Of course, there is the program here. I just print the process ID. And then there is the startup, like in every ASP.NET Core application. And I have a couple of services because I want to be able to stress the CPU, to raise the memory pressure, and take a simple state to keep the things going on. And beside that, you see that there is nothing really interesting that you should care of. I mean, there is even one thing that I want you to see, that is use the request hook. This is my own extension method, which says to use the middleware. And this middleware is very simple, is declared in these other project that you will see in a moment. There is this custom header event source. So basically it says, when you receive some HTTP context and you see that the headers contain this special name that is x-trigger header event source, please raise a custom header counter, okay? This custom header counter is something declared in these other custom event source project, which has only just a 1 class. And then you have something custom that you can raise. I just increase the number. Is a very, very simple way to create an event source. And these will be our custom trigger. And you see that just this attribute does the hard work for us, and then you're done. It's the equivalent of ETW, but in .NET Core, which is cross-platform, and so it's a good thing. Now that we have seen this test web app, and we will get there during the demo, I want to show you that another application, the stress web app. And this stress web app is best seen in here. So I will type .NET run of the test web app application, and also on .NET run even on this one. So this is the web app, and this is our stress web app. And for example, if I run the one, go, this is the first time there is the jitter. It will take some time, but if I repeat again with one, you will see that it's an immediate, okay? So we are seeing that everything is running well. So this is the client, this is the server, and what about our tool? Our tool is also this one. It's better if it runs without a debugger, because of course it can slow down a little bit as I have the symbols enabled. And at this point, I have the ability to monitor a process. And of course, you can see that there are many things like there. You can see that the test web app 17604, 17604, okay, that's it, okay? I can select this one, okay, and we start seeing the trace events. These are very important, but they will act ideally, not in this demo, as triggers. Maybe as soon as I see the CPU going on, I want to trigger a diagnostic, or as soon as I see the working set going too high, I want to trigger. Or maybe as soon as I see too many, a high number of HTTP requests per second, I want to see if the number of objects that I have in my model are adequate to the number of the HTTP requests. I can see the custom headers. I can see if there are first chance exceptions. And of course, I am not interested in second chance exceptions, because the second chance exception are the ones that makes the process crash. That's too late. I mean, there are other systems to take a dump of crashing stuff. So let's see, for example, if I repeat the request here. I make 1,000 requests, and you see that I have the numbers here going 1,000, 1,000, 1,000, and so on. So now I can, for example, make these exceptions are good because I interrupt the request from the client, and so you will see the socket exception, which is normal in .NET. And on the leak side, I can make both like a leak blob, which is one of the ones that you can see here, or I can leak graphs, entirely graphs, and you see that the memory is growing, and it's growing here, and the GC allocation are growing as well. So you have a number of requests here going on, and we see that the memory is getting bigger and bigger. At this point, I want to see why this memory is so large. I mean, it's time to see why I don't see the memory going down. I can snapshot the process, and again, this is there is the jitter now. This code is not jittered yet, so you can see 203 milliseconds. But if I repeat the process, you see 100. And this is real time, because if I repeat and repeat and repeat, you see 95, 100, and so on. So this is a very fast way to acquire the memory process from the other side. And now, what can you do? You can play, literally, with queries. And the good thing is that I created a kind of wrapper around the CLRMD in order to make it more easier to query the memory, like using link operators. And it's so nice. I mean, for example, if you are familiar with the SOS, you will know that there is dump heap stat. Dump heap stat is something, oh, this is jumping because we can see the socket being closed, and don't care. A dump heap stat is one of the most common commands that you have in SOS. And you can see the graph size that instead is not available in dump heap stat, because you have the size of the entire graph of these objects, until you go there and say, oh my God, I have a large number of byte array here. What are they there? And of course, if you are on dump heap stat, you have to make a lot of other comments in order to see the whole list, going down and say, what is there, what is there? And as I click here, you see there is a little bit freezing. We are waiting for another analysis that is happening in the memory. And also, since I am sharing the video stream, it takes quite a large amount of time on my PC. But you can see I have the research of the roots that keep this allocation in memory. So the root is a pin and a handle, and you will discover that pin and the handle in memory from a low-level perspective are static. The statics. If you have something in a static, you end up in having that. And you will discover that this object array is where the CLR keep the static objects. You then have the list of graph root, which is a list inside the static field. And you can discover this without even knowing how memory works, because there is written here, you have test web app services memory pressure service field underscore roots is static. So you know that this byte array was held simply by a static that I forgot to clear maybe after the HTTP request. And you discover things very, very easily. And another way is also to say, I want to just see my own object. I don't want to see the Microsoft ASP.NET Core. I assume there are no problems there. Test web app here in the filter, and you see that this list decreases, giving you a contains filter that tells you exactly the number of objects that are here. And a human maybe want to see how many controllers are there and so on. So it's very handy, and you can go back to the all the objects and investigate. But what else is there? There is one query that is specific starting from the static fields. So I want to see everything that is kept in memory because of the static fields. And what are the static fields here? And you can see a number of static fields, and many of them make sense, of course, but maybe not all of them. And if I again test web app, I see that there is these roots that is 57 megs, and say, oh my God, there is something that I forgot. And you understand that it's very easy to make automatic queries, looking for your namespace, the amount of memory, and say, hey, there is something wrong here. Why don't you see if you just forgot to clear the roots, and then you will get rid of your memory leaks. And then we go on and on. For example, a common research is to see if there are duplicate strings, and this string interval equals to 1000 is duplicated 1000 times. And this is something that may be wrong, maybe not, who knows. And then also get string by size. What is the largest string in here? And there is, of course, the environment, okay? But it was 30K in my machine because it's a developer box. And then I have the list of modules, and you discover how many DLLs were loaded in memory. And maybe there is a DLL that is loaded twice because you have separate application load contexts. And this is another important thing to know. Then you have the thread stack. And you can see the thread stack, but only if they are managed, and they are working on it on the CLRMD too. I don't know if I can find here, maybe in the early, or exactly. So the first thread are the ones that make you easier to find something interesting. Then there are the roots, the GC roots, and you see what exactly are those GC roots, and if you have a lot of threading overlapped data, because I have a timer, of course, and then I have the system byte and array and many other. And then object by size. What is the largest object in my process? And there is this one, of course. There are the one that I call it leaks, the blob leaks. And also non-system object by size. So I automatically get rid of the Microsoft system and blah, blah, blah. And I always only see the others. And you discover that there is this graph root, which is a structure that I have in my models here. Let me on the other side, sorry. I just forgot where I put the services, memory pressure, graph root, F12. Oh my God, I'm getting old. Okay, and that's it. I mean, you have this structure that is basically leaked because it is put inside these arrays and these roots. And this is static, and of course it's wrong, okay? Because I never clear those lists unless there is a command to clear them, of course. And this is important. I mean, you can make a lot of things here to make it able to run. And I want to show you also another feature, because it gets late for our session, that is also that you can also create dumps and open them. So if you don't care about diagnosing something that is live at the moment, I can maybe load a dump and manage a dump. And this dump can be investigated. You see, it's loaded. And this was an application, very interesting, that used two different application load contexts. And that are used, the load contexts are used to separate from in memory certain assemblies that you maybe want to unload. It's similar to what you did in the past with the app domains, but this requires collaboration in the sense that if you have some outstanding reference going to the other allocator, of course, it doesn't get freed from the memory. And for this reason, this investigation is very important. And I had long discussions with the CLR team, and they finally added a core feature inside the C++ implementation that could give me the ability to recognize the allocator name, which is so important, because if you have multiple application load context, assembly load context is of course very difficult to find the right one. So now I have the allocator name and the list of objects that are loaded inside it. And this is really another big help to find leaks that depends on the assembly load context. So I worked really hard to make all together. And by the way, this application does not use MVVM for a reason. I mean, I am very passionate with the MVVM, but I didn't use it because I wanted that everyone could just go to the click handler and see what does it happen. Okay, so it's easy to understand, because this is not the final goal. This is not an application that makes sense to use as is, unless you want to experiment. But this is just a proof of concept that you can automate the diagnostics in your production environment. So getting back to the slides for a moment, and we will see what we have seen. We have seen, first of all, the ability to subscribe certain events from the trace events that give you the ability to understand what happens. And you will find exactly this code inside the repository. And the diagnostic client, you just create a new instance given the process ID of the application you want to monitor. And then you create a event pipe provider, which specifies which are the providers inside that. And you will discover that I specified a lot of them. So you have an exhausting list inside the code. You can specify the level of information. I specified information to have them all. Then no keyword specific, I don't want to filter. And I specified the event counter interval of seconds. So I sample every second I have new data coming out from the other process. Once you have created one or more provider, because you can specify more of them, you pass the collection, it's just a list of providers, to the start event pipe session. You basically subscribe them, okay? And once you have the session, you create this event pipe event source, which is basically a real-time translator of the protocol that talked by the CLR to transmit this data to your process. And you then subscribe the events, which can be of two types. The dynamic hold is the simplest one, because you just subscribe all dynamically, and then you get a generic trace events. Otherwise, you have the typed one, and you can subscribe specific things with typed classes that give you more things. But you will discover investigating dynamically this, that you can broadly see them all. So, I mean, that's it. And once you have subscribed the events, you just call process. And process, you know, is something that is blocking. So you may want to run it inside a different thread or creating a custom task and blah, blah, blah. We already talked all about this. You can subscribe memory events, CPU events, first chance exceptions, HTTP requests of various types. You will discover that ASP.NET Core can provide you a lot of information, which is very, very precious. I just showed you the most obvious, let's see, the most demo-friendly. And then, of course, the custom events counters, because you can maybe trigger, if you are authenticated, a diagnostic just when you want. Maybe you are with your mobile phone and you say, oh my God, the website is going crappy. I want to trigger a diagnostic now. And so you log in and you say, send this request under the form of a trigger, the custom event counter, and then your application knows it and say, okay, let's dump it so that I can investigate and see what happens. So basically, this is it. And by the way, if you want to take and analyze all the code and see what happens, all the cool stuff is basically on the CLR diagnostics. So you can open this and you have Diagnostic Analyzer is the main class that is wrapping basically CLRMD, okay? And you will discover, for example, that if you want to make analysis on like dump heapstat, you see I start from object, I then group by type, I select certain things, I aggregate making sum, and then I filter telling that I don't want the ones that are lower than a certain size, and then I can order by and so on. This is so cool. I mean, you make a link query and you can see that you have a lot of information. You can play with it. You don't have to type SOS comments anymore. It's fantastic. And you also have things that can provide you some printing enhancement. If you want to use a string builder instead, you are free to do that. I also wrote some of that, like here with the print roots with the string builder. And analyzing these dumps, these queries, you will discover a lot of things that are interesting. I mean, you can play it in various ways. You can, sorry, the analysis is much better. And you will discover how the object is made and how can you find references, how can you enumerate the reference with the fields, which is another nice thing provided by the CLRMD too. And there are other queries that are very interesting there. Also in the strings, you see, if you want duplicate strings, this is a very nice query and super easy to use. Let me spend the last few minutes in order to give you what is coming, what has come with .NET 5, and what is coming even better in .NET 6, which is .NET 5 introduced the reversed communication protocol. So instead of connecting to the application that is running in production, you ask the other application to connect with you. And so you start your own diagnostic server and listen to an APC port, which is specified internally in the CLR, and you specify this diagnostic port using the environment variable so that the other application, your production environment, knows where it can connect to. At this point, when you run the application, it connects with you. So it's the reverse side and goes in the wait state. So it's just waiting. It's prepare the communication and nothing more. It does not load anything, not even an assembly. And as soon as you are subscribing an event you are interested in the same way we have seen before, you resume the app. And at this point, the application runs normally. But the communication is on this side. And you know what? You can have events on the very first boot of the application. So if you are interested in what happens in loading assemblies, you remember maybe a tool in the past, the Fusion Log Viewer. That's it. And I will show you a brief demo of that, because I also have this other, which I modified the .NET client, the diagnostic client, grabbing it from the repository from Microsoft. And I basically have this very simple application, which is a console application that starts the Fusion Debugger. And the Fusion Debugger just use link XML, so it's super easy. And this application does exactly what you have seen in the slide. So it asks this other application to open a communication channel so that we can subscribe to the loading assemblies. And so you discover exactly what are the very first assemblies that are loaded inside your application. And you have the Fusion Log Viewer. By the way, I want to write this by myself, just out of my curiosity, understand how it works. But you will find that Microsoft is preparing new tools for that. So don't be scared about having to write a tool just for this purpose. And so this is exciting because you have both the possibilities. And that's the goal of this. And you may wonder what's next. So the hard work is made from CLRMD, which is something very, very interesting that Microsoft has created to discover how to manage and read the memory in managed application. It works with .NET Framework and .NET Core, but of course, more we go on and more is .NET Core focused for obvious reason. And you can investigate on various things, but every time they release a new version, there is something exciting new. So I will tell you that to look at the upcoming features. And there is also diagnostic runtime utilities where I contributed, and I am still pushing my queries inside this other project in order to make it the standard. I mean, so that you don't need my library anymore. And by the way, all the code, everything you have seen is here so that you can experiment it. And if you have questions, both here during the session, at the end of my presentation, and now you can ask me. And I really want to thank you very much to have attended my session. And I go back from to our friends and see if something is in the chat that I haven't.
Thank you, Raffaele.
Hello.
Thank you.
So How is going?
You've just shown us the hardcore part of the engineering, that part that is so important when things get messy, right?
Yes, exactly. Because, I mean, you have to know that before or later you have some hard time to figure out what happens. And analyzing a dump is harder than managing these kind of tools. Because if you have to do it manually and start typing SOS commands, I mean, it's so boring. It's so devastating bad. It's not something that you want to do. Frankly,
unless you want to spend your weekends and nights, I don't know.
Yeah, if you know, I spent several times in debugging over the night in the past. So believe me, it's something also with the kernel debugger when the things are getting very, very bad.
When is it the right moment in the life cycle of planning and architecting an application or implementing an application to consider all these aspects? And
well,
what happens if you
the good thing is that this solution does not require that you add any code that is specific to the investigation in your application. So this can even manage it by 2 different teams. I mean, you can just let the main team of the application go for their side, and they don't have to care too much. And on the other side, my ideal situation would be to have a debugging team that knows how the application works, knows what are the objects that make sense are inside the memory process and which other does not make any sense that are there. Because we don't want a generic tool. I mean, I don't mean to install this tool on every machine in the world. That's bad. I want you to create a specific tool for your specific use case. That's the good part, because you can have much detailed information. You can maybe discover that after a certain threshold, you don't even want to care to fix that bug. That's bad to say, but sometimes it happens. I mean, we live in the real world, and you maybe want just to recycle, because if you use maybe Kubernetes, and you say, why should I care too much about this thing? I want just to drop the node and load a new one. We have to be practical. How many, you love concepts maybe as much as I do, no? And we all love music. Generally, the IT people loves music. And if you ever tried to buy a ticket in a website, you know that when there is the big moment, you are not able to even load the page because it's damnly developed so badly, no? And you discover.
Or if you want to make the vaccine, right?
Yeah, exactly. So, I mean, these are the typical use cases where you cannot spend even time in improving the application. You just want to understand when it's the case to do something. If something is up to you, I mean, you have the power to automate the stuff. Maybe you want to spin up in new machines. You maybe want to go to Kubernetes if you develop a cool architecture, as we all hope we could do in 2021. But too often we see the website installed on a virtual machine that is going crappy with the 4 gigs of memory.
Yeah. Speaking of virtual machines and thinking of the cloud, so how does this relate to the cloud deployments or the platform as a service existing out there, and the insights, the Azure Insights, for instance, how do they relate?
You know that nowadays it's very trendy to make sidecar containers in order to go side by side with diagnostic tools and so on. You can even run these two processes, let's say the application and the diagnostic stuff, inside the same container if you want. Otherwise, because it doesn't really take too much memory. I mean, it's something that you just want to understand what's the best moment to grab the snapshot. And then you want to maybe save a dump on a share, so that another application do the analysis. You don't have to do all the stuff in the same process. So maybe you want to split my tool in two parts. The one who is monitoring and understanding what's going on, and that can be done inside the same container, inside the same environment, or the same VM, and then run the analysis elsewhere, so that you don't have to bother.
Yeah, got it. So Raffaele, really insightful. Thank you so much. I'm gonna give you like 5 seconds. Maybe you know Mihaela. She's a contributor in the CodeCamp community. You might have met her at one of the CodeCamp, maybe in Yash. So hi, Mihaela. Mihaela.
Hello.
Hi.
Hi.
Okay.
I guess yes. We should have met. I guess.
Yeah. Mihaela's next with a session on architecture, the many phases of the architecture. So wish her luck for the presentation.
All the best.
In the meantime, we will have like a short break, 5 minutes, just get some refreshments. I don't know, stretch a little bit.
Okay.
And recharge batteries for the next session. Until then, bye-bye, Raffaele.
Bye-bye.
Again in Romania.
See you soon. Yes, okay. I hope so. I really hope so.